So today we're gonna be doing some coding, and then I'll be back for RP later. Oh, you can see that, but that's fine. I don't really care. All right. So, what we're gonna do is I'm gonna first. I'm kind of switch it up a bit. I'm gonna first present a problem basically, and then it's gonna already have been solved. I've already solved it, and then we'll go to another problem, and I'll answer it. The reason being, basically, I don't like this music. The reason being, I found that it's tiring to, after going through a problem, to continue going through other problems while having like talked about it. So if I'm able to have done one or two problems ahead of time and then talk about those and then just like solve a final one, I feel like I'll have more energy to be able to do that. So that's what I'm going to do. So again, the idea being that the channel is not only meant for RP, it's also meant for coding and AI and ML, and that's the kind of stuff I like doing. So I enjoy that. It's my day off, and I enjoy doing programming and AI and ML. I like to be able to practice these things. I like to be able to teach others these things. And I like to learn new ways of doing similar things, get a deeper understanding. I believe that these are freeing. The things that you can learn here are freeing for you, both financially and intellectually. I think that life is more than pursuing money and friends and all that kind of stuff. I think it can also be pursuing knowledge. And so, in my own small way, this is what I want to do here. I'm already going to be doing this stuff anyway, so I figure why not just stream it. Again, RP comes later. I usually do this stuff earlier and then the RP. So today we're going to go through a problem I've already done, and then we might solve another problem that I haven't done and like solve it together. If you have any questions, you can feel free to say something about it. I also try to discuss like, okay, why are we solving these problems? Why is this significant? Would you be asked this in a coding interview? That kind of thing. I try to give my perspective as someone who's been in the industry and I think has found some success in it. So yeah, but the biggest benefit here is that you can learn these things. You don't need a degree. You don't need a qualification. If you can prove that you can do these things, you can do this. In most companies, some will not accept you, and those places can get bent. But most places will. So a degree is a piece of paper. Knowledge is knowledge. All right. So again, we're working with arrays here. The idea being that an array is an interesting structure. An array in Java, again, I don't know Java. I'm learning along with you. So that's sort of part of the impetus here. Like, I know Python, I know SQL, I know PySpark, I know blah, 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 blah. I just never learned Java. So I was like, here's a great opportunity to learn Java. And by the way, none of these things did I learn in school. I learned all of this. I taught myself. So this is just the process that I go through when I'm teaching myself these things that have, brought me some success. Both emotionally and intellectually. So the idea being, what's an array in Java? So, unlike like a list in Python, an array in Java is a static object. And that's really important because it's basically saying, hey, computer, create an array of n objects and elements, and here's a static piece of memory, and assign that memory to that list, and you cannot expand that list at all. And that's very useful for a computer because if it's static, then it says, okay, I just know what is going to be here. This is known. Versus a dynamic array, which we can also call a linked list. These are used in computers all the time, very useful, and being able to traverse static versus dynamic lists is obviously very important in computer science and programming. I'm told, right? I take an economics perspective to most of this stuff. And so, because that's where my background's in. But yeah. So let's see here. So we have a problem. I've already solved it. As I said, I'm going to solve the one problem beforehand, and then maybe we'll do a coding problem together. And the idea is pretty simple. You've got two lists of sorted arrays. So this is actually very interesting because the idea is if they weren't sorted, we would have to approach merging two arrays very differently than if they were sorted. So we're assuming they're sorted. That means an array is 1, 2, 3, great. And we want to merge them together. We have two static objects, and we want to create one static object, and we want to retain the sorted nature of those objects. Okay, fair enough. This algorithm, like so many other algorithms here, are actually things that we encounter in real life, right? So let me just come up with an example off the top of my head. I look at my bookcase. I have a row of books that are organized. They are sorted by author, right? And then I get a stack of books. And someone gives me a stack of books, or I buy a collection of manga, right? Which really happens. And I want to put the manga into the bookshelf. Well, how do I merge the books into the bookshelf and retain the ordered nature of the books? Okay, well, this isn't very difficult. Because all we have to do is like you would do in real life, you would go up to the bookshelf and you would say, okay, what's the name of the author? The name of the author is blah. And the other name of the, you'd find the place in the alphabet where that would belong, and you would move everything to the right that is not next in the alphabet, and everything to the left that's not to the alphabet, and you put the manga in, right? The collection of manga. We're going to be doing the same thing here, right? So you get two arrays. Let's say they're sorted like this: 1, 3, 4, 5, 2, 6, 7, 8. Great. And then we want to get an output of 1, 2, 3, 4, 5, 6, 7, 8. That's literally all we have to do. So I solved this earlier because, again, I want to retain some of my energy. And here is that array, or that code. So we're going to go through it one at a time, very, very slowly. And then I will, after I've broken it down, then I'll go solve another problem. Not too bad. Okay. So what do we do here? Well, first, you get an array. Let's start down here because it's going to make more sense. We've seen before, and if you haven't seen it, go to an earlier video. You can go to like last video. You start any class in Java with public static void main with a string as the integer, or a string as the type, and a list of arguments as the argument. And then you're going to do something. So main has provided something. This is what Java expects. And then you have an action between these two brackets. Okay, so we do something. What are we doing? We are taking a list and we're creating it for ourselves. So let's just create a static list, and it's going to be a list of test argument 1 and test argument 2. And they're going to be of types integers. So we're creating an integer list called argument 1, argument 2. I should say array 1 and array 2. And we're going to give it ordered numbers. So these are both ordered in their respective of their own elements. And then ahead of time, I want to know the answer. Let's say I have an answer. And this is a really great way to approach many problems. You break down what you're trying to do, and you pardon for my cough. And the best way to do that is to know the answer ahead of time and see if you can get what you expect to get. This is very useful in coding, but it's also very useful in lots of things in life. So I know that the answer should be 1, 2, 3, 4, 5, 6. Okay, so I have the inputs, I have the outputs, and then I have this little function here that says, okay, check if that's true. It says if these two arrays equal the array that I want after putting them through some function, then I should see this output. Arrays are merged properly. Pardon me. So, what is the function? Well, it's actually pretty simple, but I don't like saying easy. It is not easy. If it were easy, you would just know how to do it right away. It's simple in that the implementation of it is intuitive. It is not easy. None of this is easy If it was easy, you wouldn't have to learn it. Easy things are things that are, you know, I just don't like calling things easy because it could be hard for you initially. I didn't know this right away. I wasn't born knowing how to write this code. So I truly try to say simple versus easy. Okay, so simply, here's what we do, but maybe not easily. So I was working this out in my mind, and so what happened? Again, this is our code, this is our canvas, this is our art. You can comment as much or as little as you want. I'm going to comment here. I'm going to say, okay, so I'm actually going to create a battle plan for myself. Let me try that. What's my battle plan? My battle plan is as follows. That's interesting that you can do that. All right. I'm going to say, iterate. This is go through. Iterate over both. Well, I'll write it like this. I need to iterate over both lists. At every element of each list, I need to ensure that the element of list 1 should be less than or equal that of list 2. If they are not equal, if an element of list 1 is not less than or equal to an element of list 2, then that is a place that we can merge the lists one after the other. Okay. So that's what we're going to do. But in order to do that, we're going to have to do the following. First, I know that I'm going to have to iterate over the list. And the way to iterate over a list, or an array, I should say, in Java and in most programming languages, in fact, this is pretty much how they do in all of them, is you have an array and you have an index. And you say, this is the ith index. So I want to find the ith index, and then I want to point to that element, and I want to say, what is that element? And then I want to compare what the ith index of array 1 is to the jth index of array 2. We don't have to say I, we can say j, we can say the up index and the down index, we can say the left index and the right index. It doesn't matter what we call them. Typically we say I and j because they're just followed after each other in the alphabet. It does not matter. And we can see that with this third index here. I'm going to get back to this because this is actually something that tripped me up earlier, and then I realized what the issue was. Okay. So we go through. But what's this thing right here? Well, I have an array here, and I have an array here. But I'm going to merge those arrays together. And as I said earlier, in programming languages with static arrays, that is, they are not dynamic. You can't just like put an element into them that past the amount of memory that they have allocated. You need to somehow create an array that will fit all of the new elements. Well, we know ahead of time what the length of these objects are. So what we can do is we can create an array, and that's what this is right here. Create a new array of integers right here. Call it new integer list of length, the length of the first array plus the length of the second array. So since we already know that, then we can do this. If we did not know this, then what we first would have to do is we'd have to go through the entire lists once and get their length just so that we can create a list of n values, right? You could actually go through and say, am I done yet? No, then add a 0. Am I done yet? No, add a 0. So this is going to be a list of n zeros where n is array length 1 plus array length 2. Okay, great. So now that we've done this, we're going to go through and we're going to create a while loop. We only need one single loop at first. And it turns out by doing this, we are going to efficiently go through only the number of elements in these lists. We're not going to iterate over and over and over again. This is pretty efficient, I believe. So here's how it works. while some condition exists, do something. What is the condition? The condition says while the ith index of array 1 is less than its length, because we start counting at 0 in Java and Python and things like that, in which case this is going to be, we have to subtract by 1 because when you're counting something, if you start 0, 1, 2, 3, then how many elements are in there? There are 4, right? But I got to the third digit, right? So you subtract 1. In this case, that's what we do. So we say while I is less than or equal to the length of array 1 and j is less than or equal to the length of array 2, do a thing. In other words, ensure that there is no out of bounds error in these arrays. Said another way, what we are trying to do is ensure that we're not looking for an element in the list that doesn't exist because we went past the length of the list. Okay, fine. So what then? So while these two things, while we're searching through these lists, if the element, I should say this, if some condition is true, then do a thing. If the condition is not true, do another thing. That is if else. Okay, what is the condition in the first if statement? The first condition is if the element I in array 1 is less than or equal to the j element of array 2, and this is what we were talking about here, then what we can do is we can say in the new array, oh, what is this? We're going to have to find out. Assign the ith element of array 1. But what is this? Well, you could, in theory, use the ith element here, and you say, okay, well, this is going to be 0, then 1, then 2, then 3, then 4. The problem is we might lose track of our index when we get down to these while loops down here, which I will talk about. So what I did was I created a third element. This index tracks the elements of array 1. This index tracks the elements of array 2. And this index tracks the elements of this new array right here. And if I wanted to be really pedantic, I could put this down here, but I don't. We're just going to say it's here. All right. Pardon me. So we go through and we say at the index of this new array, assign, since it is less than or equal to a corresponding index in j, assign it to that array and iterate 1 in I. Why are we not iterating in I and j? Well, think about it like this. You go through and you're at, let me look to the examples down here. You're at these elements right here, right? And you are at 1, and then you're at the index 0, and you're at the index 0. So this is 1 and 4. 1 is less than or equal than 4. So, okay, we would put 1 in this new list, move forward. But if we moved forward with both I and j, we would have skipped 4. We need to keep our j pointed at 4 until it is appended, because this is also a sorted list. So we say, okay, we place it into the list. Great. Move forward for I because we've already considered the first one. Is 2 less than 4? Yes. So then you put it in. Is 3 less than 4? Yes. Then we put it in. And that's what happens here. It could have been the other way around, right? J could have been less than the other list. It doesn't matter. In this case, that's what's happening. So you you iterate one element at a time. You're checking every element of the list until you've exhausted the list. At this point, we've gone through and we're changing the elements of the list every time we add to the new array by indexing it +1. But what we also are doing is when we get to the end of this list, we cannot keep going. We can't add another I because then we have an out of bounds error. But what about 4, 5, and 6? What do we do? That's why we're pretty smart here and we can say, okay, when we're done with this while loop, now check to see if I or j are less than their lengths. In this case, we've already exhausted the ith list. And since we've exhausted the ith list, we just go straight to down here where j is still at 4. And now we say, okay, just take all those elements and plug them in because this has been exhausted. And once we do that, we return the array and we're done, and we've just merged our lists. So if you go through the debugger, that is, if you go through a step-by-step breakpoint here where we say, okay, what are the values here? You go through, we're checking the values against each other. We can see this happening in action. Okay, we're at the ith index of 0, jth index of 0 for these two, which mean an emerge index of 0, which means since this starts all as zeros, go through. The first one's going to be 1. The second one is going to be 2, 3. Now we're going through j because we've already appended all of these, which means we've exhausted I. We can skip this one. Go through it for 4, 5, and 6, which is happening right here, and we're done. And now let's see if we get our result. We do. Arrays are merged properly. So if we go back here, then we'll see that if I plug this code in and I run it on all the test cases, so there's different test cases, -3, -1, I'm going to do, this works on even negatives, and it works on positives, and lists that are mixed with negatives and positives. Since they're already sorted, we're already okay, which means we've gotten through all of our cases, and if you submit this code to the evaluator, we've just passed our coding interview, and it runs in 2.86 seconds, which is fine. Great. So again, I have not taken data structures and algorithms classes. I just like to learn these things. I'm working through these myself. I don't have all the answers, and sometimes I will be stuck. But I wanted to have enough energy to go through more than one problem in a setting, and so I figured first solve one by myself, or two, whatever. Then if I have energy, I will go through one with you, and we'll try to solve it, because that can take longer. All right, so let's actually do that here. So we're going to look at the next problem in our problem set. It says, in this problem, you have to implement the find sum method, which means basically what we have to do is you have two elements in an array, and we have a search value of 27. Now, I've solved this in Python before, actually, but I haven't solved it in Java, which means it's going to be a less simple one. Now, the problem is I don't think I can solve it in the way that I would with Python yet because I haven't learned enough. So we're going to try to solve it in a different way, which is kind of cool. So basically what you do is you say, okay, I want this value 27. What elements in this list give me that? Once you find two elements that create that match, then return those two elements and you're good to go. So this is the checksum class that they give us. I'm going to copy it. I'm going to go back to my IDE and I'm going to create a new file, and we're going to call this checksums. And I'm going to create a new file, and it's going to be called checksums.java. Great. Checksums. Oh, it's called checksum. They didn't name consistently. So we have to rename this to checksum, and we have to rename this to checksum. Cool. Checksum. Okay, so we have this. We're good to go. Let's just grab this quickly because it's just easier, but you're going to have a public static void main. You know what? No, we're not going to do that. We're going to be good citizens here and write it out ourselves. Public static void main string, capital S, args. I believe that's it. Then this. What's the action? It's this thing. This is what Java expects. And now we can start doing some test code. I will take this part and some of this before so I can just quickly iterate through. And we will remove what is superfluous. That's fine. And we take this code, tab it back, grab from up here, just some stuff that's quality of life that really doesn't matter at this point. Okay, we want that. Oops. Make sure that every line ends with a semicolon. This is done. This is done. This is done. Cool. Check merge array. That doesn't exist. So this will be check sum. and it's going to have this method, and it is this, and it takes an argument. It takes an array and an integer n. So let's just take an array. We'll say this, and an integer. We're going to call this int n equals whatever. We have to figure that out, and it'll take n right here, and then an answer which we have to get. So if we go back to the browser, what did it say? The browser said, here's a test case. Grab these two, and find two numbers that add up to n. So we're going to take this, go back to our IDE. This will be our array. We'll make this. This is going to be test argument 1, blah. And then n is the number that we want to add up to, and it's supposed to be 9. Well, we already see where that's going to happen. It's going to be 2 and 7. So we know where it's going to be. And then the answer should be 9. Great. And it should not be a list. It should just be an integer. And we actually don't need arrays equal. We just need this. We just need to say find sum equals answer. Then great. And the should be an output of a list. Why should it be an output of a list? I see. The answer should be, I apologize. The answer should be 2 and 7. So we can do this. We can say arrays equals, and we want these two things to be equal. So there, and there. Now we're done. Okay, so that will be that. And we don't need equals. We would do comma. Cool. Applicable for int and int. Well, this should be this. It was complaining that this wasn't a list. Okay, so we've assigned a list. So now we've this is just to test. So first, what am I doing? Like, let's take a step back. First, what I'm doing is I'm looking at what the problem is. And the problem is telling me, hey, you need 2 elements of an array that add up to some number n. Okay, great. Then what? Then what you need to do is go through and ensure that those 2 elements are returned. Okay, fine. So what I'm building up here is just a test set to say, I know that this should work, so let me build code that resolves that. But I do this by first finding what I know to be true, and then working backwards to how can I build towards that thing. I think that's pretty useful as a method in life. Okay, so what are we having? What problem is going on here? Checksum is in its own file. Merge checksum, merge sorted Java. We can just call this checksum. Will that work? This should be fine, I think. Okay, so let's keep going. We know what we want to achieve. Now we just need to achieve it. So how would you go about solving this problem? First time I've seen this problem. I don't know what it's going to be. What do I want to do? Well, this makes sense. So this is saying create an integer list. And by the way, the code they gave us, that doesn't mean that's the code we have to use, but this actually does work. There is some array in which we want to create, which will return 2 numbers. So we already have an advantage here. We already know that there's going to be 2 numbers that need to be found. The second thing we need to do is we need to create an array that is formed from 2 zeros. So we're going to create that here. That part is good. Next, what we need to do is we need to find a 1 number, and then we need to find another number, and we need to ensure that they are different numbers. I believe, looking through this, there should be different numbers. Oh, and if no such pair is found, then return an empty array. I just saw that in my... So this is a good warning. Look for edge cases. So in this case, the edge case is if no pair found, then return empty array. Cool. So I want, just because I know that that is an edge case that I need to do, what I'm going to do is create a second test case. So this I can call test case 1. Test case 1. Brute force. Test case 2. Or we can call this instead of brute force because it's not going to be brute force. Pair found. Test case 2 is pair not found. Alrighty. Pardon me. So let's take these same things. Now let's do this. We're going to call this test argument 2, and we're going to call this test n because I can't have two things called the same thing. So we're going to call this test n, and this is going to be test n2. It doesn't matter. And this is going to be answer 1, and this is going to be answer 2. So we know that the answer for this should be an empty array. So I'll call this 0 and 0. Or it said an empty array. I think an empty array would be just... let's try this. I actually don't know. I don't know the answer. So this should be test n2 and answer 2. Great. So now we have two things we need to solve. We're not done yet. We have to create a number that can't be found in the array that we provided. So what are we going to do? Let's create a new array. Let's call it like 4, 9, 12, 17, 117. It doesn't matter. And the number that we cannot find is the number 1. We cannot find 1 in this. No matter what you do, if you add those two together, they're not going to equal 1. We know that for a fact. So it should return an empty array. Now, technically, this isn't an empty array, but we'll see. Maybe this is what they mean. Okay, so we have our two test cases. We're already addressing those. Let's go first through this one and see if it works. So we need to find if no pair found, then let's create the first case right here, which is if pair is found, no pair found, then return empty. So we're going to iterate through the array. Let's do that. So we say for I in, this is not Python, this is Java. So for some condition, do a thing. I actually find that in Java, it's much easier to do while loops. So I'm actually going to do that. Excuse me. And what we're going to do is we're going to create, how am I going to do this? I know. I'm going to create an integer, 0. Oh, we're going to call this I, just like we were familiar before. And we're going to call an integer j, and it's going to be equal 1. So there is, we start at the first element and the second element. Then what we're going to do is we're going to call this result index. And we're going to call that int equals this. This is just like our previous problem, so we're actually just trying to apply the things that we learn. People, learn through analogies. Try to take something you learned, a little nugget, a little morsel, relate it to something that you don't know, and then you'll start bridging those gaps up here, I think. That's my belief. All right, so this is from before, right? We had one index for the first array, one index for the second array, and one index for the third array. The only difference is there's not 3 arrays here. There's 2 arrays. There's the new array and the current array. But if we treat the first array as if it were 2 arrays, that is index in one element, index at another, and make sure that they're not pointing at the same integers, then actually we can use the same methodologies. So that's what we're really doing here. We're kind of expanding the strategy that we had from the array before. So while some condition do a thing, what are we going to do? While I is less than or equal to, this is going to be, we have to be very careful here. I hope I'm right. Dot length, I don't know if I'm right. Dot length minus 2 and j is less than or equal to r dot length minus 1, then do a thing. What am I doing? I'm saying, since I should always be behind j, and j should always be in front of I by 1, because we're going to go one at a time and check these. Oh, I see the problem. We cannot do that. What we really want is, hold on, let me think. 2 while loops. We're going to do 2 while loops. I see an issue, and I'm going to solve it. All right, let's try this again. I see what the issue was. First, let me just write it out. While I is less than or equal to, this is true, r dot length minus 2, that is true. Then do a thing. What is the thing? While condition, do a thing. While j is less than or equal to r dot length minus 1, do a thing. This is why I shouldn't have put them in the same while loop. I'll say it in a second. We're going to check whether elements match. So the problem that I was actually getting to, so this is exactly the same condition as I had originally, but I put them in separate while loops because what we need to do is check the first element of the list against every element that succeeds it. Then go to the next version of I and check every element that succeeds it. Then every element that succeeds it, then every element that succeeds it. It's going to be diminishing the size of how much you are hitting the elements. But if I had left them in the same loop, then it would have just been match 2, match 2, match 2, match 2, and we wouldn't have gotten all of the matches. So that's why I needed this in separate while loops. So we can just do that right here. Now we can create a condition. If condition, do a thing. So if I, and we can do this real quick. If array I and array j, that is I at some element, j at another element, equal n, then what would we do? We say return. Frankly, I actually don't need this. I realized that we can just do this. Return what? We can just say return new integer of elements array I, array j. We can just do that. Right? We don't need to create a new list for this. And then, so we're saying return a list of integers. The list of integers are these. Fair enough. The next thing that we want to do is say, okay, go through, but what if they do not equal? Then we'd say we would say j plus plus, and we keep going through. Wow, j is, okay, is this going to work? Keep going. Once we're through the loop, we go through, I goes through, j goes through. The problem is, let's see if I can solve this. We go through. Once j is, then what we have to do is we have to say j, we'd say I plus plus is this, and j equals I plus plus all right, let's see if this works. So here's what I'm thinking. We're going through the first the first element of I in the array. First element I. Then we're getting every element that succeeds it and checking to see if they add up together. Then what we do is once we've gone through all the J's, and let's say we don't get a match, then what we need to do is we need to go back to I, add it plus 1, and say, okay, check this element against every other element. And the best way to do that would be to say I plus plus. But J is still, we just went through J. We need to reset J. And what is J? J is I plus 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 1. So then we would say I plus plus equals I plus plus. But we don't want to do plus plus because I'm afraid it's going to do item assignment. So I think we should do I plus 1. That way, like, I'm not sure that it's going to, I think it's going to, yeah, so we don't want to do that. Is I plus 1. Then we go through again, we go through again, we go through again, and we match all of them. And only then, if we don't get these things, then we return new int I, an empty array. This is technically an empty array, so I feel like I should just be able to do this. Okay, we go through, let's see if this works. This shouldn't be too bad. Now the first case will work. Let's make this more complicated though, because I need to check something here. I've given 2 and 7. 7 follows 2's right away. So we're not really going to be able to contest the concern that this doesn't go through the proper way. The only way to do that is to add a new test case, and we're going to do that. We're going to take a test case, and we're going to try to answer our question. Let's go to test case. We'll call it test case 3. Test. We want to check the edge cases that we're not sure about. Test case 3, or the conditions that we're not sure about. Do we iterate properly? So we grab these. We're going to call this 3. 3, doesn't matter. 3, answer 3, test R, and then 3. Okay, so how can we check this? Let me just find a condition to do that with. Cool. That won't work. That won't work. Negative. How about this one? -8. So we take these. Oops. These conditions right here. We're going to call this this, and we're going to call this this, and we're going to take this, bring it up here. This is our new test condition. So now we're going to test these numbers, 1, -2, -3, -5, against trying to find the -8. So 2 numbers that add together. Now the answer should be -3 and -5. If we've done this properly, we've iterated through correctly. So we're going to want to check that condition too. All right. So we're looking for 3 different arrays are merged properly. But actually, we don't want merged properly. What we really want is to say is arrays, let's say, element found. Let's just say elements found. It doesn't matter. Elements found. Exclamation point, exclamation point. Great. So elements found, elements found, elements found. Cool, 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 cool. That's tight, that's tight. Right on, right on. And this should be, we're going to call this this. Okay, so let's put the debugger in. We're going to first check this one. Then we're going to check this one in our debugger. That is, we're going to go through our code. And the third one, we're going to go through this one. Great. So let's see if we screwed up anywhere. I'm sure we did, but we'll find it. Build failed. Okay, so the first things first, I have done something wrong, and I think it's about the naming conventions here. So hold on one sec. Merge, check merge array. Let's just call this rename. Let's just say some elements. Doesn't matter. I'm gonna call this rename some elements to n. There we go. Okay, so we don't need this one that we were talking about earlier because we got rid of it. That's fine, and we're calling some elements to n. It doesn't matter. So what's going on here? Test2 is, we didn't use it, so we want to make sure we're doing that. Test n2, answer 2, answer 1, test n, answer 3, answer 3. Great. And is our debugger running? No. So let me grab these and put the breakpoints in. These are called breakpoints. That's where we want to check to see if things are working properly. So we pause the code to see where we're at. So we're going to put a bunch of breakpoints for now, and then we'll make it better later. So we've just run it. Everything looks fine. We're working on the first problem. So we know what we want it to do. Let's see if it works. It goes through and it says while I is less than array blah, blah, blah. So I starts at 0, j there, and then we want to check if. So let's see. If ri plus rj equals n, what do we get? And so right now what we should get is I and j, so that should be equal to 9. So n should be 9. What do we get? Let's put a breakpoint there. We're going to a breakpoint, and the breakpoint is already returning this, and it is saying rj is, I wish we got the actual, well, let's see. So it returns for us test 9, answer 9. Did we get it? Elements found. Perfect. So we got elements found. We did correct. Now, the second thing, this is where we want our test to fail. There are no elements that should add to 1. So we go through and we say, well, I equals 1, n equals 1, I equals 0, j equals 1, n equals 1. We go through. Does this condition hold? Nope. Does this condition hold? Nope. Does this condition hold? Nope. J plus 1. Let's see if this works. J equals I plus 1. J equals 4. Does J equal 2 now? It does. Perfect. So J equals 2. So we reassign J to equal 2. That's what we wanted to happen before. That is 1 above. And so now it should be at 1. And then we're going to go through again. Does anything work? Now J is 3. Now J is 4. Now we're going to go through. J should be now equal to, it's going to be equal to 4, I believe. 3? Fine. That's fine. You go through. Does it work? Nope. And we went through and we got elements found. That's correct because the answer is that this is an empty list and we returned an empty list. So we're good. Now we just need to do one last thing. We actually just confirmed that we do iterate properly, but let's just ensure it by checking test case number with -8. We go through. We say, okay, we're starting at I and J. We go through. Do these conditions hold? No, these should not equal to -8. Go through, go through, go through. Okay, we've got to change the first element of the list. Try again. Does this work? Does this work? Does this work? Okay, nope, it doesn't. How about one more time? And we did. Oh, excuse me. -3, -8. Oh, whoops. This should be -3, -5. So that was my fault. So what we can do is just we can remove these breakpoints, or I can go here and just turn them all off. And then let's see if we get the 3 elements, because the test condition was wrong. It should have returned -3 and -5. So if I run this one more time, now without any pauses, we get 3 elements and found. So the code is correct. So now all we need to do is take this, go back to our browser, plug it into the checksum right here, see if we get any issues, and run it. It might fail on the test case of an empty, but I don't know. Okay, so it did. Or it didn't. It went perfectly fine. So this code works. And 10 out of 10 cases passed in 2.69 seconds. We just killed it. We just traversed our lists. So this is basically how I do it. So we can keep going through problems in arrays. I might jump to linked lists. I'm probably going to skip some of these problems for these coding interview problems and go from there. Oh, this is just a quiz. we might rearrange. I want to do more complicated algorithms because I need to learn some of these things as myself. Some of them I don't. But yep, that's that. And we went through 2 problems today and no biggie. So I will be back in a few hours to go through RP. But thank you very much. Have a good one.